I guess just a couple minutes on me before I introduce the panel. I'm an independent advisor, non-executive director, and STEM ambassador, primarily in the space sector. I chair the Global Network on Sustainability in Space, which is working to bring scientists and industry and policymakers together to try and tackle the challenges of space traffic management. And I'm a former chief executive of the UK Space Agency. I'm absolutely delighted to have the opportunity to speak with Martin Rees and Sarah Johnson. And I know we're all going to learn a huge amount from their massive reservoirs of knowledge that they share between the two of them. To introduce Martin, he's a world-renowned astrophysicist, the Astronomer Royal of the UK, former president of many learned societies, the author of more than 500 research papers and several books about the universe and the future of humanity. And Sarah Johnson is an assistant professor of planetary science at Georgetown University, a former Rhodes Scholar and White House Fellow. She's worked on NASA's Spirit, Opportunity, and Curiosity rovers, and is a visiting science with the Planetary Environments Lab at NASA's Goddard Space Flight Center. Sarah has a new book about searching for life on Mars coming out in just a few weeks. And I know we're all interested to talk about Mars during this session. So welcome to you both. Now, I guess let's just launch right into Martin's talk. Martin, most people joining this session will have heard about the recent SpaceX crewed spaceflight to the International Space Station. It was a world first for a commercial space operator. The global space market is changing very fast with it's attracting entrepreneurs with new business models and new technologies in fairly significant numbers. And public sector funding and private sector investment are starting to, flood in, be attracted to that market. So I'd love to hear your thoughts about those developments and anything else you'd like to talk about.
Right. Well, thank you very much. I'll come on to that, but let's think about the inspirational value of space first. And let me put this in perspective. I'm old enough to have remembered Neil Armstrong's one small step on the moon. It was an amazing achievement just over 50 years ago. And of course, that is, in retrospect, the high point of manned spaceflight. I never look up at the moon now without thinking about Armstrong and Aldrin. And at that time, I thought that it would only be 10 more years before there were footprints on Mars. But of course there weren't. The reason for that was that the Apollo program was funded by the Americans as a Cold War enterprise. They put into it about 4% of the federal budget for several years. And once they just beat the Russians to the moon, then they had no particular reason to maintain it. And the current NASA expenditure on space altogether is about 0.6% of their budget. But of course, although manned spaceflight hasn't reached the heights of the Apollo program, several hundred people have been into space, into low Earth orbit, mainly in the International Space Station. And of course, space has transformed our lives. We depend on it every day, as you know, for sat-nav, communications, environmental monitoring, and all the rest. So we depend crucially on space. And of course, for scientists, space has been crucial because we had telescopes going above the blurring and absorptive effects of the Earth's atmosphere to observe the cosmos, X-rays, gamma rays, etc. And more excitingly, of course, we've had probes going from the Earth to the planets and other bodies of our solar system. And I guess Sarah will talk a bit more about that. It's really exciting what we've learned from close-up pictures of these other planets and even from instruments that have landed on some of them. So space has been very, very exciting. But of course, we're now thinking about two new developments. One is, as you said, the commercialization of space, and the other is whether there's going to be some sort of resurgence in manned spaceflight associated with it. Commercialization of space, of course, is important. It's been the way we've done our communications for a long time, but it's been facilitated by the falling costs of launches, and that's been partly due to the great success of Elon Musk's SpaceX in cutting the costs and allowing the first stage to be reused rather than thrown away, and also by miniaturization. Space has benefited hugely from the technology that goes into our iPhones. This allows astronomers to send tiny miniaturized probes to the outer solar system, and it also allows spacecraft to launch lots and lots of small satellites. The American company Planet Lab launched nearly 80 shoebox-sized satellites in one Indian rocket, which are going to observe all parts of the Earth every day with moderate resolution to monitor field use, building sites and things like that. And of course, we have the plans of Elon Musk to launch 10,000 even smaller satellites to provide internet coverage to Africa and elsewhere. So space isn't a big science in the same way, and it's possible for quite small miniaturized satellites to be valuable. But what about the future of manned space flight? Because this, of course, we're told is what's most exciting. And to be honest, although the early Apollo program was hugely exciting, I really don't think many people were excited by all the astronauts who went into the space station. Indeed, the space station only really made the news when something went wrong, when the loo didn't work, or when Mr. Hatfield, the Canadian astronaut, sang David Bowie songs with his guitar up in space. That made the news, not the actual activities. But things may change. And of course, the rhetoric of Elon Musk is that they will change. And the reason I think that the private sector is going to be very important in manned space flight is this. If we look at what NASA did with the space shuttle and the space station, it was hugely expensive. And it was hugely expensive because they were risk averse. The shuttle was launched 135 times, and it failed twice, 2 spectacular crashes, and each of those was a national trauma because the lives of publicly funded civilians were jeopardized by those failures. And I think if NASA does anything in the future to go back to the moon or send people to Mars, then again, it's going to be expensive because they will have to have this safety culture. On the other hand, I think these private companies, provided they don't use the word space tourism, but only the word space adventure, applying is risky, I think they can cut price and take greater risks and thereby launch people into space, not just into near space, but further out at more modest costs by taking risks. And so my view, if I was an American, is I wouldn't want to spend any money, any taxpayers' money on NASA's manned program, because the practical case for sending people is getting weaker as robots and miniaturization get better. So space for humans is now an adventure. And I think we should cheer on Messrs. Musk and Bezos and their companies in the hope that they will be able to send adventurers into space, to the moon, and maybe even to Mars. And of course, the first people going to Mars may have one-way tickets, but there are many people who'll be willing. And Elon Musk himself has said that he hopes to die on Mars, but not on impact. And he might make that. I think he's 49 years old now, so in 40 years he might achieve his ambition. But even though I think it is realistic to have a small colony of people on Mars by the end of a century, I don't agree with Elon Musk, nor with my late colleague Stephen Hawking, who both envisaged mass migration to Mars to escape the Earth's problems. I think that's a dangerous delusion because terraforming Mars, though it's not impossible, is far, far harder than dealing with climate change on the Earth. So it's a delusion to think we can escape the Earth's problems by going to Mars. And indeed, I'm not sure many people want to go because not many people want to live at the top of Everest or at the South Pole. And a Martian small colony would be even less comfortable than that. We could, in principle, build a city at the bottom of the ocean. No one would want to live there. And I feel the same about the mass emigration to Mars. So my view is that Mars is going to be explored by robots. And I think there will be a few human adventurers who will go there and we'll cheer them on. But there are going to be robots also, which will fabricate large structures in space. It doesn't need people to go up to assemble a large solar energy collector or a large telescope under zero G. And I think that's an exciting development too. But let me say something about more distant future. The reason why I think these crazy adventures on Mars are really going to be very, very important for the whole evolution of life. That's because by the end of a century, we'll have far more advanced techniques for genetic modification and for cyborg technology than we have now. So it'll be possible for these people on Mars who are living in a very hostile and alien environment, which human beings aren't well adjusted, to adapt themselves to that environment. And so these new technologies, which I hope we will regulate strictly here on Earth, and where we're not motivated to use them because we're adapted to the Earth already, they will allow these people on Mars to have progeny who will be post-humans, different species. And so this will be a new kind of evolution, not Darwinian evolution, but a sort of secular intelligent design, which will be 1,000 times faster. And this will lead to post-human species emerging on Mars. And if they become electronic, then they will not necessarily want an atmosphere. They may prefer zero G, so they will go off from Mars into deeper space. If they're near immortal, a long interstellar voyage will be a deterrent to them. So you can imagine in the far future that entities, intelligences, which are in a sense our remote progeny, will spread through the solar system and beyond. And that leads to my final comment, which is in response to the question which all astronomers most often asked: are we alone? Is there any life out there? The answer is, of course, we don't know. Some people think they know. I get letters from people who say they've met the aliens, they've been abducted by them, etc. And I respond by saying, well, do you really think if the aliens made a huge effort to get here, they'd just meet one or two well-known cranks, maybe make a corn circle and go away again? I think it's unlikely. And I tell these people to write to each other and not write back to me. But having said that, it's an open question whether there is life out there. Well, I think we know pretty clearly that if there's any life elsewhere in our solar system, it's not very advanced life. There may be freeze-dried bacteria on Mars. There may be creatures swimming under the ice on Jupiter's moon Europa or Saturn's moon Enceladus, and I hope we find out in a decade or two. But no one expects advanced life in our solar system. But the situation there has been transformed by astronomers in the last 20 or 25 years, who've come to realize that almost all the stars we see in the sky are like the sun, orbited by retinues of planets. Many of those planets like the Earth, size of the Earth orbiting a stable star at a distance where water can exist. So there are probably literally billions of Earth-like planets in our galaxy. Would some of them harbor life? Well, we don't know. It's logically possible, of course, that the origin of life was such a rare fluke that it only happened once, even in the entire galaxy. We just don't know. And it's interesting that even though we understand Darwinian evolution, the simplest protozoa to humans, we don't understand the origin of life, the transition from complex chemistry to the first replicating, metabolizing things we call alive. So we don't know. But I think it's quite likely that there are going to be some signs of life on some of these planets. And I think within 10 or 20 years, we will know if there are any biospheres on any of these planets. We will know this because bigger telescopes are being built on the ground. The biggest being planned is a 39-meter diameter mirror, a telescope being built by European astronomers in Chile. It's unimaginably called the Extremely Large Telescope, the ELT, have enough collecting area to actually collect enough light from a planet orbiting another star to take its spectrum and see if there's any evidence for chlorophyll or oxygen, etc., and learn if it's got a biosphere. And you could do other things. I mean, if you could detect this planet, then you could observe if it had continents. Just like, to take an analogy, suppose there were some aliens out there looking at our solar system. They'd see the sun, an ordinary star. They'd see the Earth, as in Carl Sagan's nice phrase, a pale blue dot, very close in the sky to its star, our sun, and a billion times fainter. But if the aliens were looking at the Earth carefully, they could learn quite a bit about it, because the shade of blue would be slightly different depending on whether the Pacific Ocean or the landmass of Asia was facing them. So they could learn that there were continents and oceans, the length of the day, something of the climate, and something of the atmosphere. Those are just the things we'll be able to do in 10 or 20 years with this big telescope. Now, as to whether there's intelligent life, then I'm very glad that there are some programs being carried out now to look for something manifestly artificial, a manifestly artificial radio emission from some object or some strange artifact, etc. In fact, this morning I was attending a conference at Georgetown Bank on this sort of technology, which is partly funded by Yuri Milner, a billionaire in California. And this is worthwhile, although I'm not holding my breath for any success. So I think it's very important that we should look for evidence for life. And of course, if that were discovered, especially intelligent life, that would be important. It makes us less lonely, but in a sense, it would require us to be cosmically more modest, because if we were the only intelligent life, we could imagine in the far future that our fate would be of cosmic importance, because we could spread through the galaxy and beyond. But of course, if there's a lot of life out there already, then that's not so crucial. But the question of life is very important. And just finally, I want to emphasize that the far future is very, very extensive indeed. Just to think about this, most of you will have seen the time chart showing the emergence of life on Earth, Darwinian evolution, taking nearly 4 billion years from the first simple organisms to the present biosphere. Many people happy with that somehow think that we are the culmination of it all. But no astronomer could believe that, because astronomers know that the Earth, although it's been around for 4.5 billion years, has 6 billion years to go before the sun flares up and dies. So the Earth's less than halfway through its life, and the universe may go on expanding forever. To quote Woody Allen, eternity is very long, especially towards the end. So we should think of ourselves as just the beginning of cosmic evolution, not the culmination. However, my final remark is this, that even in this concertina perspective of billions of years in the past and in the future, this century is special. It's the first century when life can move away from this planet, first after 45 million centuries, and also, ominously, the first century when we humans collectively could, by our errors, disrupt the entire future and foreclose all these exciting potentialities. So this century is special, and I think that's an important message for everyone, whether they are astronomers or not. But I've gone on long enough, so let me stop now. Thank you very much for listening.
Thank you so much for that thought-provoking talk, Martin. There's so many ideas to follow up on there. But first, I'd like to give the virtual floor to Sarah, and then we have lots of questions, I'm sure. So Sarah, there have been 56 exploration missions to Mars so far, with about a 50% success rate. And 3 missions are launching next month, between July and August. 2 more scheduled in 2022, including the European Space Agency's Rosalind Franklin rover, which was built here in the UK. And we've already talked about how Elon Musk, has plans to also travel to Mars. So tell us about Mars exploration.
Certainly. Let's see, I have some slides. Hopefully they'll come up. And just before I begin, I just want to say what a tremendous honor it is to be sharing this stage with both you and Martin. Thank you so much for having me here. And I'd be delighted to spend a few minutes talking a bit more about robotic exploration now that we've heard from Martin a lot about human exploration. So, you know, it's been all of these centuries we've been looking up at the sky, and there have been, you know, planets like Mars have been no more than points of light for most of human history. And, you know, even the ancients, they could look into the night sky and they could see that there were these 5 wanderers, these 5 points of light that seemed different from the fixed stars. And of those, one of them had this brilliant red color. And it wasn't just the red color of Mars that made it so enchanting. It was also its motion. So Mars would drift eastward night after night against the background of these fixed stars. But then every couple of years, it would suddenly backpedal on the zodiac and go back west for several weeks before reversing its normal course. And this actually even led Plato to conclude that planets must have free will, for what could these retrograde acts be if not expressions of that free will? And so, of course, now we understand much more about orbital dynamics and exactly what's happening. And since the dawn of the space age, we've been sending missions to Mars, taking advantage of this period that happens every couple of weeks, every 26 months, when Earth and Mars align on the same side of the sun in opposition, and that the sun and Mars are on opposite sides of the Earth. And one of those opportunities is coming up very soon, and I'll get to that here in just a moment. But as you said, Katherine, yes, there have been all of these missions to Mars, 56, and half of them about have failed. That sort of outside line here. But we've been fortunate that we've had a number of successes, and we've been getting better at this as the years have gone on. So I'm going to spend a little bit of time just talking about the history of robotic exploration and some of the discoveries that we've made. So this all began back in 1965. This was the first NASA mission called Mariner 4. It was a flyby mission. And this is a really amazing image of the planning map that was used for this first NASA mission. And you can see there are these faint lines, geometric shapes on the surface of Mars. And this was this holdover from this time a century ago, when at the turn of the century, where a lot of the literate world actually believed that there were canals on Mars, this expressions of an intelligent civilization that had engineered their world to irrigate, bring water down from the melting polar caps. So in the 1960s, people no longer believed that these were canals, but there was still this remnant idea that there might be these geographic images, these lines on Mars. And so these are the images here. You can see these squares that have been lined out for the first flyby of Mars. And in fact, that these lines don't exist on Mars. There are no such geometric shapes. They're just a sort of a figment of the effects of looking through a telescope at a very, very far distance. And we had no idea what to expect when these first mission pictures were coming back. In fact, there is a wonderful story when the data started arriving at JPL, the Jet Propulsion Lab in California. They didn't have the computers working fast enough, so they printed out tiny strips of paper with these numbers and started doing a giant paint by numbers to try to figure out what these first images of Mars would actually look like. And sadly enough, it was a very bleak sort of moment, because the discovery was that Mars was covered with craters, that this was a desolate place, like even more desolate than our lifeless moon. And the New York Times, right as soon as this mission happened, declared that Mars was probably a dead planet. And again, it was just this very bleak view. Here's another image from a flyby just a couple of years later. But fortunately, we did not cease from our exploration. We continued to go back to Mars. And just in 1971, when the next set of, the first sets of orbiters went into, when Mariner 9 went into orbit around the planet, we discovered that there were images that we just completely missed, swaths of the planet that were covered with these deep river channels that could have only been gouged by liquid water. And so even if Mars today is a desolate place that's cold and incredibly dry, there was this evidence now in the form of these geologic features that Mars must have been a vastly different world early in its history. And so this is, we've had a whole slew of orbital missions that have gone to Mars from the US, from the Europeans, from even the Indians, sent a fantastically successful mission, their very first attempt to send a planetary mission a couple of years ago. And these orbiters have helped us transform Mars, really brought it to life in sort of technicolor detail. We've been able to look beyond just the visible light that we see with our eyes. We can use spectrometers to see out into the infrared, as shown in this thermal emission image of Meridiani Planum. We've been able to use incredibly precise laser altimeters to understand the topography of Mars with just really tremendous resolution. Here is Olympus Mons. You know, for a long time we thought Mars was just this very flat planet, that it was too small to have enough heat to generate much volcanism and make things like giant volcanoes. But here's the largest volcano in the entire solar system. This is Olympus Mons, and it towers over an escarpment that itself is as high as Everest. We've also been able to peer into the subsurface. This is a European Space Agency mission showing liquid water in the shallow subsurface of the planet, which is very exciting, both from a scientific perspective, as well as thinking about future human missions. And that's nothing to say of the landed assets. So we had our first touchdown on the planet's surface with the Viking missions in the 1970s. We had about a 20-year hiatus, and then we went back with little Pathfinder, the size of a small suitcase up here at the top. In the early 2000s, we had the Spirit and Opportunity rovers that touched down on the surface. And more recently, the Curiosity rover, which landed in 2012. This rover is about the size of a Mini Cooper, a large beast, but it's a mobile science laboratory, so it can drive all around and drill holes in the surface and analyze them with its onboard chemical laboratory. And we've made some really exciting discoveries looking in depth at the chemistry and the mineralogy of the surface. We found things like simple organics, the building blocks of life. We found all of the elements that are required for life as we know it. So that's really promising when it comes to thinking about possibilities for habitability. And that brings us to what lies ahead. So this guy, you can see, looks very similar to the Curiosity rover, and that's because it's built on the very same chassis. This is the Perseverance rover that NASA's going to launch into orbit next month. It's very similar, a different package of instruments. As you can see here, the instrument arm is a bit like an outstretched lawnmower. It's a very heavy instrument arm with all kinds of wonderful instruments to help look at the rocks and the bedrock and the soils that we come across, looking again for signs of organic molecules and for interesting clues about composition. The idea for this rover, well, first I'll say a quick note that the rover is going to carry along this lovely little package called Ingenuity, and it's a helicopter that's going to take off from the surface of the rover. It's about the size of a tissue box, but this will be the first time we've flown a helicopter on Mars. The idea is really as a technology demonstration to see if this kind of technology might enable all kinds of future sort of scouting the landscape and understanding where to go next from a vantage point that the rover itself does not have. And so the launch window opens July 17th. And this is when this NASA mission, the Perseverance rover and the Ingenuity helicopter, the target landing site is this exquisitely preserved river delta in Jezero Crater. And this is just an incredible site where we see river deltas have been wonderful sites of preservation here on Earth, and the rover will land and it will explore all kinds of terrains here, ancient shorelines, you know, these magnesium carbonate deposits. It'll hopefully encounter some hot spring deposits as it heads up toward the rim. And it'll spend 2 years in its primary mission doing exploration. And the main goal of this mission is to collect samples for eventual return to Earth, samples that may harbor signs of ancient life, which is tremendously exciting now that we are finally back to doing proper sort of life detection and looking for biosignatures or traces of life on the surface of Mars. And this is really a breathtakingly ambitious campaign. It's not just this mission, but really a series of 3 missions in cooperation with the Europeans and other partners to bring these samples back to Earth. So we began the process in 2020 with the Perseverance rover caching samples. So these are samples about the size of a pin light. There'll be a couple dozen of these. They'll be left in a cache on the surface of the planet. A fetch rover will be sent to pick up these samples, the cache that's been left behind, and then put them into a Mars ascent vehicle, which will go up into orbit, and then will be collected by a passing spacecraft for return to Earth for analysis in terrestrial laboratories similar to the moon rocks that came back with the Apollo program. And it's not just the American mission that's launching in July and August. So we'll have a mission, the Chinese are not only sending an orbiter, but also a lander and a small mobile rover. And this mission is called Tianwen-1. And so the orbitals will have cameras and spectrometers attached. I should say Tianwen-1 stands for Heavenly Questions. It's there's an ancient Chinese poet that that worked on this idea of Tianwen, the Heavenly Questions, and it's going to launch on a giant Long March 5 heavy rocket. The Chinese have been making tremendous strides with their launch capabilities. Again, the same window when Mars and Earth are close together. This mission will lift off. It's bound for the plains of Utopia, and hopefully, if it's successful, we'll see the small rover also come off the landing station, and it will have, again, cameras and imaging capabilities. It will be looking at surface compositions. It'll have ground penetrating radar along to try to help us peer again into the subsurface. So a tremendously exciting mission, and if successful, will be the first Chinese Mars mission that's been successful. And then also we'll have the United Arab Emirates. And this is quite remarkable. This is a country that did not even have a space program in 2014 and now is launching a mission to Mars. This orbital mission is called HOPE, or Al-Amar in Arabic. And it's going to do a suite of atmospheric observations. And if successful, we'll join, as I mentioned, India before in having their first Mars mission be a successful endeavor. So we'll hope that that comes to pass. But these 3 missions are going to be tremendously exciting. The Mars rover will land on February 18th, regardless of the launch date. It's a Thursday. You can mark your calendar. And the other missions will be arriving around the same time. Though right now it's thought that the Chinese mission will do a lot of imaging before the exact landing site is determined within Utopia, and that their landed mission may not start until sometime around April. So lots to look forward to, lots to think about. But I will say it's a really tremendously exciting time because there are all of these other folks. It's not just sort of NASA and the Europeans and the Russians. There a bunch of other space agencies that are jumping in to the mix in terms of exploring Mars, not only these Asian space powers, the Japanese and the Chinese, but we've also got, this will be the Arab world's first mission to a planetary body if HOPE is successful. And then, talk of private companies also getting into the exploration game. So I'll leave it there because I want to leave plenty of time for questions, but hopefully that gives you at least some sort of sense of what the robotic program for Mars exploration has been looking like recently.
That's great. Thank you, Sarah. It sounds like it's going to be a really busy time, actually. Actually, that was absolutely fascinating. We have some time for discussion now, but I really hope that anybody watching will also be able to join us for the Q&A after this session, because that's already raised so many interesting questions for me. I guess let me start with you, Sarah. Your new book is it's about the search for life on Mars, and it's going to be published soon. Can you tell us a little bit about it, why you wrote it, why search for life on other planets? You know, what's the point of that? And I guess what your talk raised for me as a question is also about international competition versus collaboration. You know, you've got 3 different countries sending missions to Mars in the same month. Are they all coordinated, working together, or are we people just politely trying to stay out of each other's way?
Oh, those are some great questions. I guess the first one, just about the book. So I've written a book, my first book. It's going to be published in a couple of weeks. It's an exciting time. So the book really goes into depth on a lot of these issues, thinking about the last 50 years of Mars exploration since the dawn of the space age, and how this has been this kind of deeply human endeavor to try to defy our own isolation in the universe and discover, I mean, if we're lucky once and for all, that we're actually not alone. And it tracks the history of how this planet has transformed from a distant point of light into this actual world that is every bit as interesting and complex as our own, and looks at some of the twists and turns and the blind alleys that the science has taken us down, but also the sort of human characters, the scientists that have brought this incredible tenacity to this search, and gets a bit into the existential stakes of this quest and the lengths to which people will go. So, and I guess I'm sort of one of those people. The search for life is what keeps me up at night and really motivates me to move forward. But then your second question, so I'll just say the book, it's called The Sirens of Mars, and it's being published in the US on July 7th and in the UK on July 16th, if anyone is interested in getting a copy. And then your second question, Katherine, that was also a really good one about international cooperation and competition. So we do a tremendous amount of international cooperation. The instrument that I've been working on with the Curiosity rover, the Sample Analysis at Mars instrument, that's been built in collaboration with French colleagues, and a similar instrument called MoMA will be flying on the ExoMars rover, the Rosalind Franklin rover, again in collaboration between the Americans and the Europeans. It'll be interesting too to see sort of how data sharing is handled. NASA's had a very hard line about sort of cooperation with the Chinese, and I can't even propose scientific proposals with Chinese colleagues at the moment. And the Chinese mission, a lot of the details of it haven't been known sort of in the run up to these last few years as it's been put together. But I think it'll be really interesting to see sort of what happens once data starts streaming back. And I'd love to see more cooperation, especially between the Chinese and the American scientists.
Great. Martin, I don't know if you have any reflections about that international, space is by definition, without borders. And, my impression has always been that there's the ability to cooperate from a science perspective in space, even when things on the ground might be a bit more tense. But I suspect there's also quite a lot of international competition as well.
Well, I think all Europe collaborates through ESO. That's very successful, and there is global collaboration. But ironically, of course, the initial impetus for space exploration came from the superpower rivalry. I mean, ICBMs that send bombs across, they were the first rockets. And I think had it not been for the impetus of the Cold War, the first space exploration would be done by things looking like the shuttle, emerging from aviation, whereas in fact the ICBMs gave a boost. But that's just a historical illusion. But now, indeed, things are getting more collaborative, although if the Chinese, say, wanted to send people to Mars, which they could, if they want to make a great leap forward and do more than the Americans did, that'll be done for reasons of competition, not cooperation. So I think there's a mixture. I think when we get to the smaller scale stuff, then it is going to be collaborative. Can I just say that I admired Sarah's book as well, and I think what was nice about it was it did give a feeling not just for the science, but also for what it's like to be a scientist and to be in an international group. So I think that's something which is good. And just not to be outdone, let me mention my own book, which came out a year ago, On the Future, which does discuss something about the future of space and the long-term future of humanity.
Well, let me pick up a bit on the signs of life. You know, if we do find signs of life, current signs of life, I should say, on Mars or any other planet, how do you both think that as humans we should respond to that? Should we, you know, turn those places into I don't know, national parks where human beings are not allowed to tread? How should we respond to that?
Well, I mean, I think it's certainly true that if Mars is as sterile as the moon, then we shouldn't be too concerned about people going and mining, etc. Whereas, as you imply, if it does have some sort of biosphere, even a simple one, then we feel it should be preserved as something of great scientific interest. But of course, Sarah briefly mentioned going further to the outer planets. And I think that'll be exciting because what we want to know is how likely is it that life exists in the galaxy. Now, if we could show that life had originated twice independently in our own solar system, then that would mean that it must have started in billions of places throughout the galaxy. Huh. It would be amazing if it originated twice. But there's a proviso that if it's just found on Mars and the Earth, some people would question, does it have to be two separate origins? Because there have been people saying that in a sense we're all Martians, maybe life started on Mars and came to the Earth. So finding life on Mars doesn't clinch this overwhelmingly important question of whether life is common in the universe. Whereas life on Enceladus, I think, would, because couldn't have got from there to here. I mean, Sarah may have views on this, but it seems to me that if there's life on Mars, you know, some people would say, well, it could have a common origin from life on the Earth.
Sarah.
I do have views. No, that's it's really interesting, and Martin does bring up this important idea that there are lots of other targets for astrobiology here, and even our own solar system, like Enceladus and Europa, and Titan is one of my favorite places as well, this large moon of Saturn. But I think that so there are different types of life we could find. And if we say found evidence of ancient life and it was just, you know, a particular kind of morphology or an isotopic signature, there might be, you know, some debate about, first of all, whether that was life. And then also it would be very hard to reconstruct whether or not that was a life that was very similar to Earth life or that was incredibly different, its own genesis, let's say. But I think that if we were to find extant life, living life, you know, say in the deep subsurface of Mars, I think that we would be able to analyze it with the exact same methods that we use to look for life in extreme environments here on Earth. And we would immediately say if it was DNA based, we could sequence that DNA and pin it onto a phylogenetic tree. And we could see, is this similar? Is this just a deeply branching, you know, ancient diversion from our own life? Did Mars just catch life from the next planet over? Which is certainly possible. 1 billion tons of rocks were exchanged between the planets early in their histories. But I think what's really exciting to me is this idea of a separate genesis. And I think that, you know, biology is just largely a descriptive science. I feel like it lacks the sort of underlying laws of a lot of chemistry and physics. And it's because we only have this one data point, which is life here on Earth. And I do think either way, a discovery would be of great interest. You know, we could, even if it was ancestrally related, we could replay the tape of evolution. We could take this greatest experiment in the history of science and rerun it and see how things turn out, and look at how differently a life form that had its own, say, 3 or 4 billion years of independent evolution would be. But I think that this idea of a separate genesis, like a life form unlike anything that we'd ever imagined, I think it would be so exciting, and it would give us just such constitutional insights into the nature of life itself. I think it would be as inspiring as any discovery in the history of modern science.
Martin.
One footnote.
Oh, sorry, Martin, sorry.
If there was life on Titan, that would show the water wasn't necessary, because Titan, of course, has these rivers and lakes, which look very nice, but they're liquid methane, minus 160 degrees, not water. So that shows we could have life without water, which would go against the general constraint that most people assume, which is that the habitable zone for life is a zone where water can exist. And that's why life on Titan would be especially interesting.
Yes, because most of the search for life is for life as we know it.
Yeah.
So you make a very passionate, explanation, Sarah, about what the benefits would be for us human beings to learn more, to discover evidence of life on other planets. Martin, you've very strongly made statements, about the arguing against human exploration, the need for it, the cost of it, and also, in a sense, the view that if we are sending humans to other planets, that does nothing really to solve our problems back here on our home planet. Now, some of the people watching have been asking questions around learning from the experience of trying to live in a harsh environment, like on Mars or the Moon. If we were able to establish human colonies outside of Earth, would that change how we think about our custodianship of the Earth and how we're managing climate change now, and how we manage the environment here? So that is a question that's come up. You've got a few minutes just to address it.
Yes. Well, I mean, let me say, I hope there will be humans going to Mars. I just feel they should go paying for themselves or with private sponsorship, because they're going as an adventure, and the practical need for them for manufacturing in space or for exploration is getting weaker as robots and AI get better. That's my main point.
Okay.
So I don't think taxpayers should support manned space flight, but good luck to them. But also, I mean, I'm very unconvinced by the argument that it's good to learn to live there, because if people want to learn to live in a difficult place, they can try to build a new city in the desert, as the United Arab Emirates are trying to do. They could try living at the bottom of the ocean and in some little colonies there, or at the top of Everest. There are plenty of difficult places if you want to see what the limits are of human habitability. And I don't see any particular reason of going to Mars just for that particular purpose.
And yet, not to play devil's advocate, but as you said yourself, this is a remarkable century. The first time that any species that we know of anywhere has been able to break the bounds of its own atmosphere and leave the borders of its home planet. And the space flight program gave the world an awful lot of actually great technological innovation: cochlear implants for the hearing impaired, memory foam mattresses for those of us with bad backs. What are the technical challenges, Sarah, I'll address to you, of getting a human being to Mars? And what benefits might that, what problems could that maybe help us solve back on Earth?
Well, I'm very
okay. Go on, Martin. And then we'll give Sarah her last few minutes.
Sorry, Sarah.
Okay, Sarah.
You go first. Yeah.
Just about the technical challenge. I mean, they're legion. There's so many at the moment, like just even the life support. I mean, humans are just sort of bags of biology, and you have to sort of keep all of those systems alive. And that's very challenging. We're still doing studies about bone density and the radiation exposures. astronauts would likely have to build a base like sort of deep underground, perhaps in a lava tube, to protect themselves from the really punishing radiation environment there at the surface of Mars. We're still working on propulsion technologies that could make the trip faster than just the sort of 3, 2, 1 bang chemical propulsion that we've been using a lot of lately. The mental health aspects are still being explored. We have to sort of make sure that folks can endure such a long time away. But the one thing I will say is when I think about the state of technology when we were in 1957, in the days before Sputnik, and within those 12 years, you know, we had people on the moon. And I think that the technological leap from where we are today to where we would need to be to go to Mars is a much smaller one than actually going from nothing to people on the moon. And again, as Martin mentioned, you know, we have to have the investment, you know, as wartime expenditure, essentially. Like, that's the only thing it's been comparable to, the amount of money that we put into the Apollo program in the 1960s. And perhaps that will come through another space race or through the private sector. You know, perhaps billionaires will decide that this is their legacy and they want to invest funds in it. You know, we'll just have to see what the next couple of decades bring.
I think we should cheer them on, but I'm very skeptical about this spin-off argument, because the space stations are the only artifact that cost a 12-figure sum. And no one could say it justified that for the science it did. Maybe with death aids and things like that, and the new ways of growing crystals and all that, but it certainly didn't justify itself that way. And I think it's very hard to justify manned spaceflight. And of course, let's not forget just how uncomfortable it's going to be to live on Mars. And of course, it's going to cost 5 times as much to bring you back as to have one-way ticket. But the first thing that will happen is people going on a trip round the backside of Mars and back without landing. It will take 400 or 500 days, and that's the next step after going around the moon and back. And it's not inconceivable that this could happen in the next decade if people wanted to do it. It's been said that the ideal crew for that would be a stable middle-aged couple. Middle-aged, they don't care about the radiation dose.
If there's anything we've learned from lockdown, that stable middle-aged couples are, you know, as rare as signs of life on other planets at the moment, probably. But I think what I'm going to do is start to wrap us up there. I know that we might be slightly late with the Q&A. The moderators are telling me, but I think rather than launching into another, really interesting new topic, what I'd like to do is to say, you know, that you've left me anyway, both of you, reflecting both on just how exciting exploration still is and why we do it, but also I really like the concept that our planet is still in its infancy. And that we can't possibly have reached the peak of our achievements as a species, and that, you know, it gives me great hope for the future of humanity. So I think I'll wrap it up there and ask everybody, you know, to please join us for the Q&A session. Hi, Anushka.
Hi, thank you all so much. All I have left to say is a huge thank you to Katherine, Martin, and Sarah. You have been charged with such a beautiful topic on Earth, Mars, and humanity. And for anyone watching that has lots of questions, we've been overrun with questions on Slido, which is fantastic. Please do click through to the breakout Meet the Speaker, where we'll be continuing the Q&A session for the next half an hour. That will kick off in 5 minutes' time. And if you're here tuned in to the Planet Smart Cities and Space stage here at CogX 2020, we're going to be starting our next session at 6 p.m. in 5 minutes. And delighted to announce that we have a NASA astronaut, Christina Cook, who will be joining us with Isabel Hamilton.
Want access to more CogX videos? Subscribe now for free at cogx.co.